Nope, don't power off. Oh, not recording. Alright, perfect. So, today's objective, we're going to talk about using that unit circle you got the other day to evaluate trig functions. So, if you don't have that nice yellow unit circle that you received out, get it out, because you're going to need it today. If you don't have one, I'd probably make sure I get one. Remember, you only get one of these, and you get to use it on your test. If you have anything written on here that I do not tell you can write on here, it will get ripped up, and you'll get a new one. You can write your name on it. That is acceptable. Yes. So before the test, I will go around and I will check everyone's unit circle. If I do not find it satisfactory, it'll get ripped up, and you'll get a blank one. You will get to keep it forever and ever and ever. For the final, yes, I'd probably keep it for the final. Alright, so, the unit circle. So first things first, let's look at it. Right? We talked about how we found all these values. We found them using special right triangles. Now, we didn't actually go and find those values using the special right triangles. We just told you that's where they come from. We're not going to take the time to go through, solve them all with special right triangles and figure them out. So you just got to trust us they come from there. The one thing I would say about writing on the actual unit circle is you can change 2 pi and you can write equals 4 pi over 2, 6 pi over 3, 8 pi over 4, 10 pi over 5, 12 pi over 6. Right? Those equivalent numbers to 2 pi. I don't care if you put those on there. That's fine. Right? 4 pi over 2 can be reduced to 2 pi. 6 pi over 3 can be reduced to 2 pi. 10 pi over 5 can be reduced to 2 pi. Those are just equivalents. If you want to put it on there, you can. It might help you. I don't know. The other thing we're going to put on our unit circle is what all of these values are. So when we look at any graph, we normally say it's x comma y, right? When dealing with the unit circle, it is the cosine comma the sine. What that means is, at any certain degree, the x value at that degree would equal the cosine. At any certain degree, the y value would equal the sine. So up here, sine of theta equals y. Cosine theta equals x. Yes, Violet?
So we can write anything that you hold in red?
Anything in red on there you can write, yes. So the tangent is also the same as the sine over the cosine. Right? That's one of the identities, you haven't learned that yet. But tangent is the same as sine over cosine, which means it's the same as y divided by x. Now you can write it as y over x, but I'd also write it as like y divided by x, like write it out like this, and which is the same as y times 1 over x, or times the reciprocal. Because a lot of times when we do tangent, we're going to get fractions. We can't divide fractions, we keep change flip. Right? So, same thing over here. Cosecant is the same as 1 over sine, so it would be 1 over y. Secant is the same as 1 over cosine, so it would be 1 over x. And cotangent is the same as cosine over sine, which is x over y, or x divided by y, or x times 1 over y. So anything in red you can have written on your unit circle. Do we have any questions about that? Okay, so what we're going to do now is we're going to take different trig functions and use our unit circle to find their value. So if we start out with, if you look in your note packet, I believe it is right along the top of that page right there. That's where we're starting.
Can you go back?
Can I go back? Yeah.
For like 2 seconds.
Yep.
Okay.
Good? Alright. So if I look at the first one here, it says we want to know the value of cosine of 315 degrees. First thing I'm going to do is I'm going to know cosine. I am looking for a value of x. So now I would write that down so I know I'm looking for x. Okay? Now, where I'm going to look for x is going to tell me by the degrees or by the radians we use. So this one's 315 degrees. So what I'm going to do is I'm going to go to 315 degrees on my unit circle. I'm going to look at that ordered pair at 315 degrees, and I know the cosine is the x value of that ordered pair. What's the x value? Square root of 2 over 2. So cosine of 315 degrees is square root of 2 over 2. That's my answer. That's it. The next one, cosine of negative 210 degrees. There's a couple different ways you could do it. You could start at 0, and you go negative 210 degrees around. That's perfectly fine. Or, we could also find the positive value for that. Right? How we would do that would be, take 360, because it's 360 all the way around, and subtract 210. We would get 150 degrees. So once again, the cosine tells me I'm looking for x, and I'm looking at 150 degrees, or negative 210 degrees, however you want to say it. So I go on here. I look 150 degrees is right here. I want the x value of that coordinate pair. So it would be negative square root of 3 over 2. Does that make sense? We all good so far?
Yeah.
Any questions? Okay. The next one's a little trickier. The cosecant of negative 240 degrees. Well, cosecant is equal to what in terms of x and y?
1 over y.
1 over y, right? Or, if you want to write it, 1 divided by y. Okay? So I'm looking at negative 240 degrees, otherwise known as positive 120 degrees. Right? Either use a negative or positive, doesn't matter, it's up to you. So I'm looking at positive 120 degrees. Positive 120 degrees. I want the y value, so I need to put 1 over y, or 1 divided by y. Square root of 3 over 2. Well, 1 divided by square root of 3 over 2. Do we divide by fractions? No, we multiply by the reciprocal, right? So this would be the same as 1 times 2 over the square root of 3. Well, 1 times anything is itself. So this is 2 over the square root of 3. Do you think that we're going to leave a radical in our denominator? No. We need to do what with it? What's that vocab word? Rationalize it. Right? So to rationalize it, multiply by square root of 3 over square root of 3. On top I'm left with 2 square roots of 3. On bottom I'm left with 3. That would be my answer then. 2 square roots of 3 over 3. Make sense?
Yeah.
Alright. One more to do. Tangent of 210 degrees. Well, tangent we said was y divided by x. Well, if I look at 210 degrees, right here, I'm going to take the y value, divide it by the x value. So negative 1/2 divided by negative square root of 3 over 2. Once again, we don't divide by fractions, we multiply by the reciprocal. So keep change flip, negative 1/2 times negative 2 over square root of 3. If I multiply that out, I get 2 over 2 square roots of 3. Is that a good, viable answer?
No.
No.
No. 2 reasons. What are those 2 reasons?
Radical denominator.
We need to rationalize the denominator. What else?
Simplify.
Simplify it, right? 2 over 2 is the same as 1. So I'll just cancel out to 1s. I'm left with 1 over square root of 3. And I'm going to do what Q said. I need to rationalize it. So 1 over square root of 3 times square root of 3 over square root of 3. Our final answer should be square root of 3 over 3. Does that make sense? Do you have any questions so far? Need to make sure we're simplifying. Need to make sure we're rationalizing. Okay? Alright, that was all in degrees. What do you think we're going to try next?
Radian.
Radians. Let's try some radians. Alright. You'll notice on the unit circle, it not only has the degrees marked, but it has the radians marked right above them. Or below them, right next to them. Now, if you're comfortable working with the radians, you're more than welcome to keep it in that form. You're more than welcome to find it on there in the radian measure. Do you have to? No, what could you do? Change it to degrees, right? If you'd rather work in degrees, change those radians to degrees. So the first one, sine of negative 17 pi over 6. Well, we could work in radians, or we could change it to degrees. What do you want to do? Change it? That's fine. We can do that. Negative 17 pi over 6 times. What do I multiply by to get to degrees? 180 over pi. Good. All right. Pi's cancel. Negative 510. So I'll write that here. Negative 510 degrees. Okay. What do I do with that? What should I do with that, you think? 510, that's more than once around, isn't it?
Yeah.
So can I take 360 off of it?
Yeah.
Alright, so if I take 360 off of there, which in this case would be like adding 360, it's a negative, I'm left with what? Negative 150 degrees. Okay? So now we're looking for the sine of negative 150 degrees. Okay? Well, I like using the positive degree measures. I don't know about you, but that's what I like to use. So negative 150 degrees is the same as positive 210 degrees. So I'm looking for the sine, which is y. I'm looking for the y value at 210 degrees. So 210 degrees, looking for the y value. In this case, it's negative 1/2. So that would be my answer, negative 1/2. Okay? Did all that make sense, what we just did there?
Yeah.
Do you have any questions? Okay, let's try another one. The next one, the secant of 23 pi over 6. Well, should we change it to degrees? Okay, let's do that. 23 pi over 6 times 180 over pi. Pi's cancel. What is it coming out to in degrees? 690 degrees? So 690 degrees. Once again, that's more than all the way around the circle once, so I'm going to take 360 degrees off of it. We're left with 330 degrees. Alright, so we want the secant, which is the same as 1 over x at 330 degrees. So at 330 degrees, I need to use the x value, which is square root of 3 over 2. So 1 over that, or 1 divided by square root of 3 over 2. Which, same thing, can't multiply by can't divide by a fraction, so I multiply by the reciprocal. 2 over square root of 3. And then we need to rationalize. Right? Square root of 3 over square root of 3 should equal 2 square roots of 3 over 3. Alright? Hey, if you're doing a problem, and like you're changing it to degrees, or you're taking 360 off, and you don't get an angle measure that's on the unit circle, do you think that's plausible?
No.
Do you think we would do that to you?
No.
No, we wouldn't. If you don't get a measure that's on there, try it again. Make sure you did it correctly. Right? We're not going to give you like 75 degrees and then not tell you what the x and the y values are. That won't make any sense. Right? So it's going to be a value that's on there. Do you guys want to try the next two on your own, or do you want to keep doing it together? Do them on your own. Do them on your own. Time out of here. Is that 34? Okay. Sure. So do the next two on your own. I'll do them on the board in a second, and then you can check your answers with mine. Try them on your own. I need a calculator too. Alright, once you finish, you can check your answers at mine. I got 2 problems after that.
Oh.
Do we need more time? We can give more time.
Cliffhanger.
No. We still figured it out, huh?
Did you give us a hit?
No.
Why?
It's not really good on.
Yeah.
Grace. That's Grace. That's Grace. You had it right.
I got it right?
You had it right. That's Grace.
She gave me a look. I thought it was wrong.
If this is a piece of wood, you'd say you'd take, what are these things you call it? Those pieces that are cut out of it, what are those called? Starts with an N. I'm pretty sure it's an N. It's an N, I think. Top notch.
I didn't get it.
Usually there's so many.
I think notch is an N. Yeah, not good. N-O-T-C-H, yeah, that's what I thought. Don't tell me I'm wrong.
I don't know.
That's a bad one.
Alright, hey guys, any questions on those two? Any questions so far? Hey, back up here. No? Okay. Then, let's go the opposite way now. Right? We want to find out angles between 0 and 360 that satisfy these expressions. So before we gave you the trig function, and we wanted the answer. Now we're giving you the answer, and we want the degree measure. That goes to the trig function. So let's look at it. Secant theta equals 2. How we're going to do this is, well, what is secant theta the same as in terms of x and y?
1 over x.
1 over x. 1 over x. Well, 1 over x has to equal 2 over 1. Right? Well, if 1 over x equals 2 over 1, what does x have to equal? 1/2, right? They're reciprocal. So what I'm going to do is I'm going to look on my unit circle and I'm going to see where are all the places that x equals 1/2. Well,
60 and 600.
right here,
300.
No, I lied.
300, yeah.
So what we are going to do is we're going to write both those down. You need to write both the degree measure and the radian measure. So it's going to look like 60 degrees, comma, is that pi over 3?
Yep.
And then 300 degrees, 5 pi over 3. So work it backwards. Change this to whatever it is in terms of x and y. Then figure out what is either x or what does y have to equal and find that on your unit circle. So the next one, cosine theta. Cosine is the same as x. So x equals negative square root of 2 over 2. Where does that happen? What two values?
135 and 225.
So 135 degrees, comma, 3 pi over 4. And what was it, 225? 225 degrees, 5 pi over 4. That's it. Finito.
Well, now.
Time of yesterday.
34.